Hey class, it's Mr. Florio. I'm going to do a couple examples from section 6.3, which is separation of variables. Separation of variables is just a technique to solving differential equations. There's a bunch of techniques, but this is the one that we're going to spend the most time with. Um, we've done it a few times already. The idea is step one, if you see y prime, write it as dy dx so that we can at some point separate the y's from the x's. Uh, Step two, we're going to group the x terms with the dx and the y terms with the dy. Step three, integrate both sides. Don't forget the plus c. And then, if possible, isolate y. So, if you need to pause the video, pause it and copy it down. But here's some examples that we're going to look at real quick that are pretty straightforward. The first step, let's write y prime as dy dx. And now let's group the x terms with dx and the y terms with dy. So I can multiply both sides by y to get the y dy together and multiply both sides by dx to get the x's together. So now I'm left with y dy equals x squared dx. Now if I integrate both sides, which is step three, I'm going to get 1 half y squared equals 1/3 x cubed plus some constant c. And that's it. And, the book might multiply both sides by 6 to get rid of the fractions. But for now, this is fine. If we want to isolate y, we can multiply both sides by 2, but I'm just going to leave it alone for now. Uh, Another example, it's already in dy dx form. Now we just need to get the x's together and the y's together. So I'm going to multiply both sides by dx. So now I get the x squared minus 3 dx. I just need to multiply both sides by 6y squared to get the y's together. So 6y squared dy equals x squared minus 3 dx. And then we're going to integrate both sides. That's going to be 6y to the third over 3. That's going to be 1/3 x cubed minus 3x plus some constant. So what do we get? 2y cubed equals 1/3 x cubed minus 3x plus c. Okay. Um, and here's another one. I see a y prime, so I'm going to rewrite it as dy dx equals negative 8 cosine of pi x. Now the x's are already kind of together. I just need to move the dx over. So multiply both sides by dx, and that goes away. And now I can just integrate both sides. So the antiderivative of y is just 1 half y squared. Now negative 8 cosine of pi x. The pi x is going to make it a little tricky, but we can use u substitution there because there's a composition or even inner function of pi x. So if I take that to be u, du is just going to be pi dx. So 1 over pi du equals dx. And so we're going to have the integral of negative 8 cosine of u. And the du, assuming the dx can be replaced by 1 over pi du. So that's going to give us 1 half y squared equals now the antiderivative of cosine is sine. So it's going to be negative 8 cosine of u plus c. Oh, and we still have this over pi. So the last thing to do is just replace the u in terms of x and we're done. So negative 8 over pi cosine of pi x plus c. That is the solution to that differential equation. So straightforward examples, collect your x's, your y's, and then integrate. And you might need a u substitution, which we can do. So this example, find the general solution. It's the same thing. We're going to find the solution, meaning what is y, and there might be a plus c, which makes it the general solution. So I'm going to first write y prime as dy dx. Now I need to get my x's and y's all together. So what I can do is multiply both sides by dx. And I can, let's see, I can divide both sides by y to get the y over here. So I'm just going to do that to start, and there's going to be another step involved. But now I have 1 over y equals x dx. So now I need this x squared plus 4 on the other side. No big deal. I just got to divide both sides by x squared plus 4. So I have 1 over y dy equals, I'm going to write x dx. No, this is fine. X dx over x squared minus 4. So now my x's and y's are all together on their own side of the equation. So now I can just integrate both sides. The antiderivative of 1 over y is the natural log of the absolute value of y. And the antiderivative of x over x squared minus 4, we have a quotient here. But I see the bottom function, x squared minus 4, its derivative is 2x dx, and there's an x dx here, so I might be able to use substitution again to get rid of this quotient. So if I let u be x squared minus 4, du would be 2x dx. So half of du would be x dx. And now I can replace that x dx with half of du over u. So the natural log of y equals, let me just clean this up a little bit. So this is equivalent to saying 1 over 2u du. So the antiderivative of that is going to be 1 over 2 times the natural log of the absolute value of u plus c. And I can replace u with x squared minus 4. So is that a plus 4? Yeah, plus 4. Now, x squared plus 4 is always going to be positive, so I don't even need the absolute value anymore. Right, x squared is always going to be 0 or bigger. Plus 4 is going to make it 4 or bigger. So now we exponentiate both sides. So e to this equals e to this. The natural logs go away. There's one property of of logs here. The natural log of let's see. If I have a times the natural log of x, that's equivalent to the natural log of x to the a, meaning if it's being multiplied by a constant, it can go into the exponent. Where we actually use the backwards direction of that right here. If I take the y in the exponent, I can bring it down in front, which is kind of what we did. So this 1/2, that's the constant, I can move it to the exponent. So this can become e to the natural log of x squared plus 4 to the 1/2 plus some constant. And now we got to do a couple things. Let's see, this is y equals the natural log of x squared plus 4 to the 1/2 times e to the c. And e to the c is a constant. So, and those undo each other. So I'm going to have some constant times x squared plus 4 to the 1/2. And the 1/2 is the same thing as the square root of it. So this is the solution to that differential equation, which had a little bit more going on than the first two that we looked at. Anyways, one more example. Find a particular solution. So we're going to actually be able to solve for c when I plug in 0. When I plug in 0 for x and 1 in for y to solve for c. So we've seen this before. But anyways, take a minute to copy it down, and then we'll see if we can solve it. So I got dy dx kind of already separated. I'm going to move this xy dx to the other side. So I have e to the negative x squared times y squared minus 1 dy equals negative xy dx. Now I need to get this x squared out of here, and one way I could do it, I mean, you can divide both sides by e to the negative x squared, but equivalently, that's the same thing as multiplying both sides by e to the positive x squared. because if we take e to the x squared times e to the negative x squared, we add the exponents. And x squared minus x squared is 0, so we get e to the 0, which just cancels out. So I get y squared minus 1 dy equals negative xy e to the x squared dx. So just divide both sides by y. And our variables have been separated. Y squared minus 1 over y dy equals negative x e to the x squared dx. So now we need to integrate both sides. This first side, the denominator just has a y in it. I could separate that into y squared over y and 1 over y. The y squared over y, one of the y's will cancel out. And then this will be easy to integrate. That's just going to be 1/2 y squared minus the natural log of absolute value of y. This side I have e to the x squared, but I also have an x here, which is derivative of x squared. So we can use a u substitution here. If I take u to be x squared, du is going to be 2x dx. And I want a negative x. I'm going to just divide both sides by negative 2. So negative 1/2 du equals x dx. So this is going to be the integral of e to the u, and then the negative x dx is going to be negative 1/2 du. So it's going to be 1/2 y squared minus the natural log of the absolute value of y. And it's going to be negative 1/2 e to the u plus c. Now replace u with x squared. Okay. Now I'm going to actually try to solve this equation for c now. We're given y of 0 is 1. So I'm going to replace 1 for y and 0 for the x's. So I'm going to get 1/2 times 1 squared minus the natural log of 1 equals negative 1/2 e to the 0 squared plus c. So 1 squared times a half is a half. The natural log of 1 is 0. E to the 0 is 1, so I'm just going to get a negative 1/2 plus c. Add 1/2 to both sides. 1/2 plus 1/2 is 1. So c has to be 1. So the particular solution is one half y squared minus the natural log of the absolute value of y equals negative 1/2 e to the x squared plus 1. And this isn't an equation where you're going to solve for y by itself. It's just not going to be in the cards, but we do have an implicit equation here of y. Anyways, that's it.